Hello everyone. Today we are going to discuss about the Floyd Warshall algorithm. This side Dr. Nitin Sharma, Assistant Professor, Department of Information Technology from Ajay Mahagar Engineering College. So why we use a Floyd Warshall algorithm? Basically, Floyd Warshall algorithm is, as you can see here, we are using for all pair shortest path. It is basically used for the find out the all minimum shortest path between the nodes. So first of all, we can just see here what is Floyd Warshall algorithm. So the Floyd Warshall algorithm is used to find out the shortest path between all vertices in a weighted graph. Okay, it differs from other shortest path algorithm by using each vertex as a pivot to determine the shortest path. What does exactly mean is what every vertex is using as a pivot element. So suppose there is a graph. So suppose 1, 2, 3, 4, and the vertices are connected to each other like this. Okay. So what we are doing, we are just finding the shortest path. Suppose this is node 1, this is 2, 3, 4. So what we are doing, we are just every time, suppose there is a path between 1 to 2. So we have to be checked that if suppose I am using a third node, so maybe that is the cost is to be minimum, right? So suppose this is the cost is 6 and this is 2 and 1. So if I am going to 2 by the 3 node, so the cost is 3. So this is the way I am going to solve this. We are going to solve this problem. It can be applied to both directed and undirected graph without negative cycle. So there is no negative cycle in the graph. If there is a negative cycle, so you can't apply a Floyd Warshall algorithm on particular graph. Okay. Next is the algorithm utilize dynamic programming. It is basically based on a dynamic programming to state previous computing path for overlapping subproblems. Okay. So it is classified as one of the all pair shortest path algorithm. The algorithm is implemented using the adjacency matrix representation of graph. Why we need a adjacency matrix? Because through the adjacency matrix, we can just compute it one by one, and every time when I'm computing the next matrix, because the nature of the dynamic programming, the previous output is to be continued in the next matrix. So all pair shortest path, what is basically the problem? Problem is that find the shortest path between every pair of vertex of a graph. So like suppose we are having here 4 nodes, so we have to be find out the path, shortest path between the all the pairs. Like suppose we are having here 4 node, 1, 2, 3, 4. Okay, so what we have to do, 1 to 1 is basically the 0. 1 to 2 is the minimum cost. What is the minimum cost? So minimum cost should be written here. 1 to 3 the minimum cost should be written here. What is the cost of minimum? 1 to 4 the minimum cost should be written here. So this is the way you can see every node in the adjacency matrix. Every node to the every node is having the minimum cost. This is the problem. Okay. What is the precondition? Precondition is that it should be applied on a graph, and it may contain negative edges. It may be having a positive or negative edges, no problem at all, but no negative cycle there. Okay. If the graph is having any negative cycle, so the first step is you just remove the negative cycle. After that, you can just solve it. If there is a negative cycle, you can't apply a Floyd Warshall algorithm on a particular graph. Okay. What is the representation? Representation of a weighted matrix is like any edge, if I is equal to j, like vertex I and vertex j is equal to like this one, 1 to 1. So the value, this is I and this is basically a j. If you can see, the I value is 1, j is 1. If both are equal, so the weighted should be 0. This is the thing. Because if you are going to cost one node to the same node, if there is a cycle, so the weight is 0. Next is weight I to j is infinite if there is no edge between I and j. If there is no directly path between I to j, so the weighted is infinite. Okay. And the next is weight ij is equal to weight of the edge. Whatever weight on a edges is given, I to j, you can write on a adjacency matrix. This is the representation which we are going to use in a matrix. Okay. So I'm just explaining here what are the notations we are using. If the node are same, like I is equal to j, 1 to 1, 2 to 2, 3 to 3. So this is the way you can see the diagonal values are becoming a 0. weighted as 0. If there is no directly edge between I to j, so you can just write a infinity. And if there is a weight, you can just simply put in the matrix. Okay. Now, we have shown principle of optimal applied to the shortest path problem. So this is basically giving an optimal solution. Next. So this problem is basically solved in a 4-step. So here is an algorithm. So step 1. So the step 1 is construct an adjacency matrix. Adjacency matrix A, which all the cost of edges present in the graph. If there is a no path between two matrices, mark the value as infinity, as I told you earlier. And you can see here, if there is no edge between I to j, you can just write in a simply infinite. Okay. What is the step 2? Step 2 is like derive another adjacency matrix, matrix A1. Okay. So initially when you are going to create a matrix, so that matrix name is A0, the initial matrix, right? And after that, you can just derive another matrix, that is A1 from A, keeping the first row and first column of the original adjacency matrix intact in A1. And for the remaining value, say I1, Ij, if this is the formula, you can see Ij is equal to, is greater than A of Ik plus AKJ. Then replace the minimum value, whatever it is. Okay, either A1j with the this one value, if this is possible, right? So otherwise, do not change the value. Here in this step, k is equal to 1, first vertex acting as a pivot element. Okay, so this is just an algorithm. I'll just explain with the example also. Don't worry. In the step 3, you can just repeat step 2, all the vertex in a graph by changing the value of k value for every pivot element until the final matrix is achieved. So initially, suppose you are having here 4 vertex. So initially you have to calculate A1, then you have to calculate A2, then A3, then A4. So this is the value of k. So k is equal to basically going to 1 to 4, right? If you are having a 5 step, so the value of k is going to 1 to 5. So this is basically a repeating element until all the vertex should be covered. All the vertex should be considered as a pivot element. Okay. And the final adjacency matrix obtained in the final solution with all the shortest path. Okay. So the final, that means A4 matrix is having the solution with all the shortest path. So this is basically the algorithm. We are going to apply one by one steps. So let's understand with the example. Okay. So I am applying here step 1. So what step 1 is saying that remove all the self loop and parallel edges. Keep the lowest weight edge from the graph. So suppose there is a graph. What does it mean basically? Suppose there is a graph and this is the node 1, this is the node 2, and this one and this one. This is 5 and this is 3. So what you have to do? You have to be remove this 5 and you have to be consider the shortest path, that is 3, right? Understood? In the given graph, there is neither a self edge or nor a parallel edges here. I am taking us here a simple example. There is no self edges and no parallel edges. Okay. So the first step is already done in this graph. No need to be worry about it. Now, write the initially distance matrix or adjacency matrix. We are going to write this one. So you can see in this graph, this is the very smallest thing I am taking here. Okay. So you can see in this graph, we are having here 4 nodes, that is 1, 2, 3, 4. There is no self loop and there is no, we can say that self edges or parallel edges here. Okay. And all the edges are connected and this is a directed graph. Okay. So in the step 2, what we are going to do, we are just creating a adjacency matrix, that is A naught. So how you can do this? You can just creating a edge like 1, 2, 3, 4. 1, 2, 3, 4. So this is our adjacency matrix. As I told you earlier that you can see here, this is the thing which we are going to use to create the adjacency matrix initially, right? So 1 to 1 is 0. Obviously, if this is I and this is j. Okay. So whenever I and j are equal, so you should be written as 0. So this is 0, this is 0, this is 0, right? Another is if there is no path between. Okay, so one by one we are going to check 1 to 2. So 1 to 2 is there, that is 8. 1 to 3, 1 to 3. No directly edges are here. So what you have to write here? Infinity. Got my point? 1 to 4. 1 to 4 edge is available, that is 1. Similarly 2 to 1. So 2 to 1 is there is no directly edge here. So what you have to written here? Infinity. So this is the way you can just write a adjacency matrix, that is A0. Similarly, you can fill all the points. I can just go on the next step. Okay, so you can see I am creating here the matrix. Matrix name is, I have written here D. D, you can either write a or either write a D, whatever you like. It is just a notation which is basically going to represent, this is a matrix. Matrix name is D here, and 0 is representing the initial matrix. Okay, so you can see here what I have done earlier, 1 to 2. So 1 to 2, 8. 8 is here. You can see 1 to 3, there is no directly path, so infinity is here. 1 to 4 is 1 is here, and similarly you can see 2 to 1. 2 to 1, there is no directly path, so infinity is here, and you can see the diagonal is 0 here. Okay, so similarly you can just write a matrix D0. So initially what you have to do, first of all, the step 1 is that in the step 2 or according to the algorithm, step 1, you have to create the initial matrix, that is D0. Okay, now the second step. In the second step, what you have to do, you have to create a D1. And in the D1, what you have to do, you are taking 1 as a pivot element. Okay, so like I'm going to create a D1. So D1 is equal to, this is the matrix 1, 2, 3, 4. 1, 2, 3, 4. Okay, you can just understand this thing. Okay, so obviously the diagonals are 0. So I have just written there 1, 2, 3, 4. Okay, so whenever you are taking a vertex as a pivot element, what you have to do first, I'm taking here first. Okay, so the first row is this one, and the first column, you have to be written there. There is no changes value in this one, so we have written there 8, infinity, 1, and I have written here infinity, 4, and infinity. Okay, so the first row and the first column, because I am taking the 1 as a pivot element, so the first row and the first column I am taking as a fixed value. There is no changes in this rows and columns, and all the others value are basically based on the formulas. Okay, so how? So suppose I am going to write here D, I am calculating D1 of 2, 3, right? I am going to calculate D2, 3. Just understand one time this one. Okay, so is equal to minimum. There is a minimum function you have to call here, and you have to write here D0, 2, 3, comma. Okay, I take an eraser here. This one I'm writing. Okay, so yeah. Okay, next is D0. Now what we have to do, we are going to 2 to 3 and 1 as a pivot element. So I'll just take as a 1 as a stoppage point. Okay, or we can say that a 1 is taken as a middleware, right? So what you have to do, you have to go from 2 to 1 plus D0, 1 to 3. Understand my point? So what we are doing here, if you want to go 2 to 3, so just take a step 2 to 1, then 1 to 3. So 2 to 3 cost you can conclude here. Okay, is equal to minimum D0, 2, 3. So D0 is here. So 2, 3. 2, 3 is 1. Right? 1. And D0, 2, 1. So 2, 1 is infinity plus 1, 3. 1, 3 is also infinity. So you can see 1 comma infinity. Infinity plus infinity is infinity, right? So what is the minimum value? Minimum value is 1. So what we have to write here, that is 1. Got my point? This is the way you have to be calculate every values here, right? One by one, one by one. Okay. So if I'm going to write a formula for this, so let's understand this. So D, K, I, J. Every time what we are going, if I'm going to solve this through the programming, so we have to take a variable. So like D1, so D1 I'm taking here K, okay, and IJ 2, 3, you can see 2 and 3 is IJ, which I'm going to calculate it. Here you have to be called the minimum function. Got my point? D0, so D K minus 1, right? Obviously, right? Whenever I'm going to calculate D2, so D2 is written there either D1, D1, D1. So we are getting the value from the previous matrix. Okay, from IJ right, comma. Okay, next d k minus 1 I comma k plus dk minus 1 k comma j. So this is the formula, as you can see. I'm just calculating this formula from this one. Okay, every time this is calculating. So what we are doing here, we are just applying a function in a loop, I, j, k values, and I is starting from 1 to n, j is 1 to n, and k is 1 to n. Okay, so every time I'm going to apply this one. Okay, after the first matrix. So this is the way you just calculated the value. Okay, I'll take one more value here. I'll just calculate it d1. I'm just calculating this one. That is 3 2. And 3 2 you can see here infinity. So I'm just writing here 3 2 is equal to minimum of d0 3 2 comma d0 3 1 plus d0 1 2, right? So is equal to minimum d0 3 2. So d0 3 2 if I'm going to see here 3 2, that is infinity. So this is infinity, comma 3 1. 3 1 is 4 plus 1 2. 1 2 is 8. So what is the minimum value? So you can see 12 is the minimum value, infinity is here. So I can just write here 12. Okay, I'll show here two value. First is 2 3, where the value is remain unchanged. You can see the 1 is already there. So 1 is because the minimum value, and this is basically the infinity. So if I'm going to calculate the minimum value from infinity to 1, so that is the 1. So I have written there, that means it is unchanged. But I'm going to calculate the another one, that is 3 2. So the previous value is infinity and the new value is 12, because if I'm comparing both of them, 12 is the minimum value. I can just update it here. Okay, so this is the way you just calculated d1. Step by step you can just fill this d1. Okay, I just go into the next slide and you can see here. So d1 is calculated from the d0, and if you can compare that, this one value is I am automatically previously calculated 1, and this one is I am calculating 12 is here, right? So both the values match here, and if you can see, diagonals are same. Okay, 0 0 0 0, and I am representing here through the dotted line because I am taking here 1 as a pivot element. So this is the remain unchanged. And if you can compare to the d0, so 0 8 infinity 1, 0 8 infinity 1, and 0 infinity 4 infinity, 0 infinity 4 infinity remain unchanged. Okay, so the row and column or 1 is unchanged, and all the other elements you can see, if something is minimum, that as it is, and something is having change like 12, and you can see this infinity to 5, and these values are remain unchanged here. Okay, so my updated matrix is d1 is here. When I am taking a pivot element, 1 is here, right? So using the Floyd Warshall algorithm, write the following 4 matrix: d1 d2 d3 d4. So one by one we are going to calculate it, these matrix d1 d2 d3 and d4. Next we are going to calculate it d2. Sorry, d2. So d2 is the matrix which I am going to calculate it from the d1. Okay, so this is the d1 matrix. When I am taking a pivot element 2, so the first step is you have to do is the second column and the second row remain unchanged. So you can see 0 infinity 0 1 0, that is remain unchanged, and this one 8 0 12 2, that is remain unchanged. Okay, because I am taking here the 2. So the value of k is now 2. Got my point? So this is the way you can just calculate it d2, and all the others value you can calculate it one by one. I can just check one. You can see this one. This one is infinity in d1, and here is 9. How it is calculated? Let's check. So d2 of the value is 1 3. I'm going to calculate it here, right? So minimum d1, that is 1 3 comma d1, and the value k is 2, so 1 comma 2 plus d1 2 comma 3, right, is equal to minimum. If you can say D1 1 3, so 1 3 is infinity, comma D1 2, so D1 2 that is 8, and D2 3 2 3 that is 1. Okay, D1 2 1 2 that is 8 value, 2 3 2 3 that is 1. So I have taken here 8 plus 1 that is 3. Oh sorry, D1 3 is infinity. I have just mistakenly written here 3. So that is infinity. So if I can compare infinity between 9, so the minimum value is 9. So that's why I written here 9. Got my point? So similarly, you can just fill the matrix and you can get the output as a D2, right? So I have taken a D1 one vertex as a pivot element, then 2 as a pivot element. Now we are going to create a D3, and D3 is basically created from the D2. Got my point? So D3, whenever you are going to create a D3, so what you have to do, you have to be taken a third row and third column. So third column is 9103. So you can see here 9103 is as it is, and the third row, that is 41205, the third row is remain unchanged here. Okay, and some of the values are updated. Okay, so I'll take only one here, so I can just check this one. Okay, so you can see in the D2 2 1 is infinity, but in the D3 2 1 is 5. Okay, now the value is k is equal to 3, and for the matrix of D3, and we are going to calculate here 2 1 is equal to same function we are calling here, that is k minus 1, that means 2 ij, that is 2 1, comma next is D2 2 comma the pivot element is 3. So what we have to write here, D2 3 plus D2 3 1, right? So I'm taking here 3 as a pivot element and 2 to 1 is the range. Okay, is equal to minimum D2 2 1. So D2 2 1, 2 1 is infinity, either this one, comma D2 2 3 2 3, that is 1, and 3 1 3 1, that is 4. So if you are going to check in between infinity and 5, so the minimum value is 5. So D321, you can see here 5. Got my point? So this is the way you can just update it all the values in a D3. Okay, I think you understand that how we are going to create a from D0 to D1. Similarly, we created a from D1 to D2. Similarly, we have created from D2 to D3. Next, the next task is we have to create a D0 D4, because we are having here 4 matrix. So this is the last matrix we are going to create it. After that, we can get the final answer. Okay, how? So whenever we are going to create a D4, so what you have to do? The fourth column and the fourth row remain same. So 1650 you can see here, and 7230 is here. Both are same. And if you can see, there is 2 values are changed here to 3 values. Okay, if you can see 8, 9 and 12 are changed here. Here become a 3, 4 and 7, and all the others value are remaining same here. Okay, I'll just show you only one. You can check anything. Okay, so like I am k is equal to 4 here. I am calculating D4. You can take here 3 2. Okay, 3 2. I am going to calculate 3 2 is equal to minimum D k minus 1, that is 3, and the pivot element sorry, that is 2, comma D3 3 comma 4 plus D3 4 comma 2. So 4 I am taking here as a pivot element. Okay, so calculating minimum D3 3 2. So 3 2, that is 12. So already the previous value is 12. Now D3 3 4 3 4, that is 5, plus D3 4 2 4 2, that is 2. So you can see if I'm going to compare this. So 12 and 7, what is the minimum value? 7. So we are putting 7 here. So this is the final matrix we are getting here, because all the vertices are covered as a pivot element 1 by 1, 1, 2, 3, 4. Okay. So the last matrix D4 represents the shortest path between every pair of the vertex. What exactly means is, okay, like suppose I just want to know the shortest distance between 2 to 4. So that is 6 here. I want to know the shortest distance between 4 to 2. 4 to 2 is 2 only. Got the point? So this is the way you can just get the answer and find out all the shortest pair path between the vertices. Okay. So for the analysis, for the procedure code given earlier in the steps, the Floyd Warshall algorithm operates using 3-4 loops to find the shortest distance between all pair of vertex within a graph. Why we need a 3 graph? Because we need to I, for j and k. We need to create a 3 graph. Okay. For the first vertex, we have to cover all the vertices. When I am taking a pivot element 1. Okay. So this is the way you need to be a 4 loop. Therefore, the time complexity of a Floyd Warshall is n cube. Suppose there is a n element, n number of elements. So because all the loops are running from 1 to n, so n into n into n. So that why n is the number of vertex in a given graph. So the algorithm is basically having a complexity is n cube. The space complexity of the algorithm is n square, because we need to be store adjacency matrix in a memory. So we need to be a n number of n by n matrix. So we need a space is n square. So this is the way you can find out the all pair shortest path by using Floyd Warshall algorithm, and the complexity is, I can see here, n square, and the space complexity is the Floyd Warshall algorithm complexity is n cube and the space complexity is n square. Okay, so this is the question which you can try at home. Okay, after this lecture. So this is, I am giving here a graph. This is the matrix, and you can see I have put already 0 in the diagonal, because if I and j both are equal, so diagonal values are 0. If there is no direct path, like you can see 3 to 1. So 3 to 1, there is no direct path. So I have written there infinity. So if there is a no path between the vertex, direct path, so I have written there the infinity. And if there is a direct value, like you can see here, 2 to 4 is 2. So 2 to 4 is 2. So this is the weight I have already written there, right? So matrices I have already created. You can just note it down. Pause the screen and take a screenshot. And after that, you can solve the problem and put the solution in the comment box. Okay. So thank you for today. Thank you so much.